This video is brought to you by Hackers Against Hoodies.
Hey everyone, now on location here today at a brand new block of flats that a friend of mine's just moved into, and there's got a bit of network equipment in the cupboard, and it follows on from my last video showing what goes on in the air as far as Wi-Fi is concerned. So I thought I'd share with you a bit of a look as I dig into what the thing's about. Okay, so this is a bit of a scan, not even showing all of the SSIDs, but you can see there's a lot of them called Gigafy, and also a lot of this LG wall mount AC. So they have air conditioners here that are LG, so that's what that'll be. So anyway, I'm going to do a quick packet capture and just see if I can grab some of these. But one thing you can notice is most of that's on the 2.4 gig band. There are some up the top here in 5 gig, but there's a lot of crap here, especially the air conditioners. In fact, not just in 2.4 gig, but on the same channel. And as I showed in the last video, that gets very messy very quickly. Okay, so this is the aircon, this LG unit. So that wall mount thing that I was talking about is this. And if I have a close look at the serial number, you might have the MAC address or something that corresponds to the SSID. That's usually what they do. They put the bottom end of the MAC address as the SSID. But that explains the aircon. So there's a few in this unit, which means you add them up with all the units, that explains all those SSIDs in the air. Okay, so what I've got here is aero dump, just switching between channels 1, 6 and 11. And as you can see, it's absolutely swamped. But I'm doing a packet capture in the background. Oh, you can see I've just captured a WPA handshake up there. But anyway, I'm doing a packet capture and I'll look at that in Wireshark briefly as well. Okay, so as you saw, there were a bunch of Gigafy SSIDs, so I've just picked one here. And as expected, it goes down to 1 megabits for the bit rate. And because there's so many around, there's going to be a lot of interference. So what I'll do is I'll have a look at that now on the RF using the HackRF. Okay, so that's looking at the 2.4 gig spectrum. And you can see, well, down here on the waterfall, you can see the activity mainly between channels 6 and 11, which is about here and here. Now there's no clients in this flat that I'm in, and a lot of these flats are still empty because it's brand new. So that's pretty much just background noise, and you can see obviously it's going to fill up the 2.4 gig like I showed in the last video. Okay, so what I'm going to do now is join the Wi-Fi of this Gigafy thing, and I'm going to do a packet capture at the same time. So I'll just start the packet capture and get on the network. Now let's see the 8,000 networks here. Okay, so now we've got some sort of traffic flowing. And there's no account being set up on this or anything, it's just the initial check. And as you can see, there's crap going. So let's see what happens if, okay. You can see straight away it's got the open network login page, so it knows there's a captive portal of some sort. Okay, so what you can see is the EPOL frame, which is me joining the network, and then the DHCP. So let's have a quick look at DHCP. Okay, I've got an address. I don't see a MAC address OUY that I recognize, like some sort of Cisco or something there. It's just a generic looking one, that's okay. What else have we got? Let's have a look at DNS. So that 172.16.11.1, if I have a look at DHCP again, that came from also 172.16.11.1. There you go, it's got DNS and this 8291. Okay, so that was round about as expected from the Wi-Fi side of things. 1 megabit bit rates, a heap of them around this block of flats, and some sort of login to use it. But what I'm going to do now is tap into the wired side and just see what's going into that device. And to do that, I'm going to use a couple of wire taps here. So one for the transmit of each direction, and I'm going to feed that into a couple of little USB network adapters like these, and capture the traffic that's going between there. Okay, so I'm just going to unplug this, and sure enough, the power went off, so that was a PoE device as expected. So what I'm going to do now is put it in, put this tap in line, and just plug that back in, get that thing powering up. And what I'm going to do here is plug a couple of network cables into this tap. So what I'll have, piss that off for a sec. What I'll have is the transmit from that line going to the receive here, and the transmit from this one going to the receive. And with these two, I'm going to plug them into these network interface adapters here, and then do a packet capture on the laptop. In fact, I'll do that from the start. I'll just unplug that and set the laptop up ready to go, then plug that in and power it up. Okay, I'll start with the LAN side capture. And you can see there's a lot of this black stuff here on CDP. That's simply because I've done some modifications before doing this, so that I've just swapped the real name for Topol Tech dummy packet name, so you don't see where the place actually is. But, you know, the whole name was there. So let's start here. There's some CDP. You've got the device ID, obviously. usual stuff that you get on CDP. So that's floating around there. And if you have a look, let's just have a look here. You can see that it's coming from all over the place, which surprises me a little bit because like LLDP will only show that port. I don't use CDP much, but you can see that we're seeing all sorts of devices here. So this gig D4, F7, blah, 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 F8A, all the rest of them, they're all there. So you can tell their LAN MAC address as well. So that's coming from all over the place. Bit of info there. But anyway, I just wanted to do that one first to point out why this is showing up as errors. You can see here, checksum error. That's because I modified what it was actually saying just to mask it for this video. So anyway, not CDP. So what else is there? So we've got this MNDP, which was a new one on me. I'd never heard of that. So MikroTik Neighbor Discovery Protocol, same kind of thing. But as I said, I've never seen it. But it's the same kind of thing. But one thing, so there's the identity coming out again. But one thing I noticed is this is a UDP thing here going to a broadcast. And the source address it's using is all zeros. Now, I did a video a while back on raw sockets because they were what was used for DHCP discover packets because they're the only sort of packets that had a source address of all zeros, but apparently this does too. But anyway, you can see it's using UDP, so it's spitting out everywhere as a broadcast. So this is going all over the network, unlike LLDP, which we'll get to in a minute. You can see LLDP, but let's just have a look at this first. You can see the same sort of thing, identity, route, same kind of stuff. Software versions, the board, blah, blah, blah. And if you look at that MNDP, you can see that it's giving out some information about the board that it's using, which apparently turns out to be one of these. And again, I'm not familiar with any of this stuff. I'd never even heard of that protocol before, but it just shows you the info that's floating around on a network there. Now, I saw this one here coming from an actual address, and I had a look at that, and I saw that it had a VLAN. So I'll just quickly have a look at VLAN stuff. So anything that has a VLAN, you can see there's something extra here that's not the normal sort of comms in all these things, but something else here. So you see it's coming from the core, some sort of core that they've got. So anyway, that was that. So not CDP and not MNDP. So what else we got? Let's have a look at Radius. Radius is here. So what are these things doing there? They're sending stuff. Let's have a look. Usual stuff that's in Radius. Again, an identifier. It's a dummy packet at the moment, but it was giving out identifiers of who it was. Now, I only captured one direction of this at the start of this thing. You can see in the PPP stuff, which I'll get to. There was only one direction at the start of this. I think I bumped my adapter, but it goes both ways. So there's Radius floating around there as well. So let's just piss that off, and not Radius. Now the PPP stuff, as you can see, it's starting off with, actually I'll just get LLDP out of the way. There's LLDP, same sort of thing as before. Router board, yep, the name, more info floating around the network. Another thing too with LLDP is it tells you the VLAN ID that it's using for the port. Even though it won't be tagged, because there's no tagged VLAN in the traffic, you can see that it's apparently VLAN 30, so it'll just be an access port on VLAN 30. So PPP, it sets up PPP at the start. So that's how they're running it. I don't know why, but that's what they're doing. And as I said, I only caught one direction of the comms at the start of this capture, but it was enough to show you that the password's there. Now I've put a dummy password in, but the password was there for the PPP authentication. So that was nice. So you can see everything after that, like the last part of it, configuration. You can see that's where it gets its IP address. So that's what this unit was, 10.1.1.2.3. So you can see it's not a DHCP client, everything's over PPP. So all of these packets here you'll see are encapsulated by PPP. Now there's an 8-byte overhead for PPP. I did a video on that, God knows when, if you want to look more into that. But it's something that you'd have to keep in mind. So that's that. So what have we got here? We've got NTP. Now that time server falls into this network here, which is Gigafy, which makes sense because that's what I'm looking at here. The reason I haven't filtered out PPP yet is because everything's in PPP, and if I filter that out up here, everything will go. So anyway, let's have a look at DNS. That's just going to a local address here. You can tell 10.1.1.1, that's just some sort of server they've got there. Again, I missed the comms on the return, but you can see here, straight after it did that, it started doing stuff to this address here, which is probably this cloud MikroTik. So
cloud stuff, of course. So that's that, and given that that's the only UDP stuff in here, more of it there, I'll just get rid of UDP. So, and not UDP. Who's left? So we've got some TCP stuff here, and you can see it's port 22, which is SSH, but it's funny because it's coming from some other server, not this thing, because this thing's address was .23. So it's going from there doing a sync to here. This sends a SYN-ACK, which basically kind of informs it that there is an SSH server, because it responded with a SYN-ACK, but then that far end sent a reset. So it's kind of like a port scan, not a port scan, but just checking if that port's open, not scanning the whole lot of them, just 22. So it's like it's checking that 22 is there, and then just resetting the connection immediately. So that's that. So I can't do not SSH here because it doesn't know that's SSH yet because it didn't get past the three-way handshake. So I have to do not TCP.port equals 22. I'll get rid of that. And what are we left with? PPP, just the PPP stuff, which I went through. And of course, these echo requests and replies just happen periodically during any sort of PPP connection. The thing about using PPP, I mean, I think it's a bit unnecessary. It would have been probably better if they used 802.1x and used like EPTLS, then the password wouldn't be visible. But anyway, I didn't set it up. Now have a look at the wireless side, and I've got my little profile here with the colors. So I've got purple for data frames, blue for control frames, and this beige for management frames. And when you see red, that's a retry. So going through here, if I just have a quick look at just the data frames. Wireless LAN frame control type equals 2 for data frames. Okay, so these are data frames that could be anyone, just anything on that channel. Channel 6 in this particular moment. You can see there's a lot of red there, so there's a lot of retries going on, and it is one of these router board things. That's someone in that building there. But anyway, they were getting some data through. So that's that. But what I'll have a look at is our good old beacons from, I don't know, anyone, one of these Gigafy things. And you know what it's going to have. It's got our mates, the 1 megabit rate. Now these devices do operate in 5 gig as well. I was just doing the packet capture on 2.4. I didn't look at the 5 gig, I just had to stop somewhere. But as expected, they've got these 1 megabit rates enabled, which you know how I feel about that if you saw the last video. So anyway, that's them. You can see some stuff in there, and obviously there's the network name and you know, a whole bunch of stuff. And if you go down here, you got they've got WPS set as well, which you know that was done years ago, but still floating around. And what I want to show you is one of the probe responses. I'll just find a probe response. I always forget the thing. So wireless LAN frame control 0. That's management frames, and not wireless LAN frame control type. Don't laugh at me. Don't laugh. Subtype. So that's management frames that aren't beacons is what I did up there. Because probe response. This is what I want. So probe response. Just right click that. Apply as filter. That's what I should have put there, but I never remember them. Anyway, probe responses. You can see even probe responses. Look at all the retries. They're great. And these are like air conditioners that are like Sonos is just probing whoever. There's just crap in the air. But anyway, on these probe responses from this Gigafy stuff, you can see right down the bottom, I've dummied it out again, but it gives away the device name. Now the device name had some info there, which is just sending out in the air, but I've masked that out for this as well. Now if I look at the LAN and the wireless LAN side by side, you can see on the LAN side, as you know, all the units give out their unit information here, and you get a source MAC address from it. So I've just filtered by this one that I've got in front of me. And if I go to its Wi-Fi, what I notice is the MAC address is only a few digits different. Okay, so it goes A044C3, A044C8. So there's only 5 numbers difference between them. So what you can do from that is pretty much, I would say, because I can't confirm, but all the other ones here that have the unit names for all the other units, you could just get their MAC address and it'll be in the vicinity of it for the Wi-Fi ones. Now, I only had a single one here to test, so I can't really confirm how well that correlates, but it'll be something similar anyway. So given that information, you could figure out which SSID, because that's just a random looking SSID, you could figure out which SSID goes to which unit there. And then what you can do is just go then what you can do is go back to see data frames, and you'll be able to figure out which BSS ID is which unit. So basically, you can be able to tell who's doing what data in the unit, or you could just walk past the doors with a spectrum analyzer and see the data flowing through the air. So that's just a bit of an idea of what floats around in one of these new block of flats here. Now, if you were just walking past this place doing a packet capture, you'd just see this kind of stuff here. You'd see the beacon info, and you'd see data frames that are encrypted. Anything internally you'd have to have physical access to, like I did. So that's pretty much that.
Okay, so there it is. I just wanted to share with you what a typical setup might look like in one of these block of flats. So the key things are, there's a lot of things transmitting in 2.4 gig with 1 megabit bit rates, which, as I showed in the last video, really does create a problem. We have things like air conditioners, which also are part of that, and also the fact that you're pretty much locked into what they offer as part of the building install. But like a good network admin, I like to see what's going through the network. So that's why I just had a bit of a tap in there to see what it's about. Anyway, just thought I'd share that with you. So till next time, take it easy.